This is Chapter 5, Data Encoding and Transmission. All forms of electronic signals originate from digital signals. Digital encoding takes place when a network interface card converts data into a digital pattern acceptable to the network media. After the data is encoded into a digital pattern, it's placed on the network media. A digital signal is an electronic signal that has discrete values. Discrete values can be on and off, high or low, 5 volts and 0 volts, 5 volts and minus 0 volts, any different discrete values. Digital signal that fluctuates between a positive volt value and a 0 volt value is called a unipolar digital signal. Other electronic circuit designs fluctuate between a positive voltage level and a negative voltage level. This pattern is called a bipolar digital signal. Another important characteristic of the digital signal is the time period. The time period represents the rate of recurrence of an expected signal level change. The time period used to encode digital data should not be confused with the term time period used when talking about frequency or cycles. By changing the transitioning pattern and fluctuation pattern of a digital signal, many digital encoding schemes can be created. Non-return to zero, or NRZ, is a special classification of digital encoding. The signal fluctuates between the high positive voltage and the low negative voltage without ever returning to zero for any measurable period of time. There are two modes of transmitting data between 2 points. They are synchronous and asynchronous. In synchronous transmission, the digital signal is synchronized with the reference signal to ensure proper timing. The timing of the digital signal is extremely important for decoding some variations of digital encoding patterns. In asynchronous transmission, no reference signal is present. A reference signal is not needed if there is a way to determine when a byte or stream of data begins or ends. Some data transmission schemes use a series of ones and zeros to identify the beginning and end of a byte or stream of data. A long period of no digital signal can also be used to signify the beginning. Data from one point to another across a network or the internet, data has to be packaged with extra information to ensure its delivery and integrity. Often, data is broken into smaller and smaller deliverable pieces. Each piece is called a segment and contains information to aid in reassembly. Signals can become corrupted for different reasons. Some of the causes can be crosstalk, electromagnetic interference, loose connections, faulty or improperly grounded equipment. A parity check is a method of verifying the integrity of transmitted data. One way to ensure that data sent from the source to the destination is intact is to include a parity code with the data. So rather than say 8 bits of a byte representing alphanumeric symbols, maybe 7 bits could represent the symbols, and the 8th bit could represent the parity code. On the destination end, the parity is checked against the other 7 bits, and if the data is found to be corrupted, the destination rejects the data and requests it be resent. Normally, all the parity bit is going to say is whether the adding up of the bits is an even number or an odd number. So it's not going to be a very in-depth check. However, there is another kind of check called a cyclic redundancy check, or CRC. It's based on the same principle for error detection as the parity check, but the CRC is more sophisticated. The main problem with the parity check is if an even number of bits is corrupt, the corruption can go undetected. The CRC uses a complicated mathematical algorithm to determine if one or more bits are corrupt. A CRC can, and you get the word checksum for the CRC. A CRC can detect the corrupted bit and correct it without requiring the data be retransmitted. The only drawback is a CRC requires more data that has to be also sent. The extra data is the parity code. This slows the data transmission rate. Still, the CRC is a popular method of verifying data. It is incorporated into many different network protocols when data integrity is critical. After the data is divided into segments, it is encapsulated into packets. Encapsulation is the process of adding information to the segment that identifies such things as the source address, the destination address, the end of the segment, and the size of the segment. This additional information is called a network header. Packets are limited to traversing only LANs. If the data will be sent through a router or gateway, it is further encapsulated. A packet that is encapsulated with information needed to travel outside a LAN is called a frame. The frame contains additional information such as an IP address. An IP address is different from a machine address, the MAC address. The machine address is sufficient when delivering data on a local area network. The terms segment, packet, frame, datagram, and protocol data unit are often used interchangeably when discussing blocks of data. You can think of all of the terms as units of data transferred between 2 points. The general term PDU, or protocol data unit, is the most technically correct because they're all some kind of protocol data unit. It's awkward to use this PDU in conversation. Consequently, technicians tend to use the term packet, possibly frame, sometimes segment, to represent all data types. Communication between two computers can be classified as either connection-oriented or connectionless. In connection-oriented communication, a communication is first established between the source and the destination computers before any data is transmitted. And then after the data is transferred, the connection is terminated. In connectionless communication, the data or commands are sent without an established connection. After the data is transferred, there's no need to terminate or release a connection. IP is a connectionless protocol. In contrast, TCP is a connection-oriented protocol. The best of both protocols is used when using both TCP/IP in a wide area network communication. Connection is first established with the TCP protocol, and then data is transferred with the IP protocol. After all data has been transferred, the connection is then terminated with the TCP protocol. Connectionless protocols are used to stream audio or video data. Time is very important when conducting a conversation, and the fastest protocols for transferring data are connectionless. A connection-oriented protocol would slow the transfer of voice data since every frame of voice data would have to be verified. UDP is a connectionless protocol that requires minimal system resources. Think of a connectionless protocol as one that makes its best effort to send a command or data to a destination, but has no way of guaranteeing its arrival. A connectionless protocol typically depends on reliable equipment, such as dedicated line or leased line, to ensure delivery. There are two main categories describing the way data routed between 2 points. They are packet switching and circuit switching. Circuit switching establishes a permanent connection between 2 points for the duration of the data transfer period. Packet switching does not use a permanent connection. Packet switching breaks the data transmission into smaller parts called packets. The internet uses packet switching to send data between 2 points on the internet, such as a home user and a web server. When a web page is downloaded from the remote site to the home computer, the web page is broken into smaller packets. The packets are sent out onto the internet and may each take a different route to their destination. There are many different coding standards or data codes for representing the written word. There are also many standards used for representing images, audio, sound, multimedia, video, any kind of data. Data codes must be converted back and forth for data exchange to take place. One of the ways that we exchange text is ASCII text. That stands for American Standard Code for Information Interchange. It was an early attempt to standardize data codes. There are 256 characters of which 32 codes are command codes and 96 codes represent characters found on the standard keyboard. ASCII files are sometimes referred to as plain text files. They contain no special alphanumeric characters like bold, italic, or underline, and the ASCII file format is the most easily interchanged file format used by word processing programs. And you can even make art out of them. IBCDIC, or Extended Binary Coded Decimal Interchange Code, was an early IBM character code similar to ASCII. It is still widely used on IBM mainframe computers. You've heard Unicode before. Unicode is similar in principle to ASCII, but it uses 16 bits to represent individual characters. By using 16 bits, it expands from 256 possible characters to over 65,000 possible characters that can be represented. Another data standard, especially in the internet, is Hypertext Markup Language, or HTML. It's an authoring language used to create documents that can be downloaded from the internet, viewed by a web browser. Part of the HTML language is a standard set of color codes. The color codes are inserted into the coding of a web page, and when a web browser interprets the page, the color code is translated into the color that the code represents. So let's talk again about the OSI model. The OSI model is sometimes referred to as a protocol stack because it is, in essence, a stack of protocols. Various protocols are associated and designated to work at different levels of the OSI model. At the application level, the user interfaces with network operating system. The application layer is the top of the OSI model and is the start and the final destination of data communication. Data leaves the application layer and enters the presentation layer, where raw data is packaged into a universally agreed on form. The session layer establishes dialogue between the source and destination computers. It's easier to visualize the session layer as a negotiation rather than a layer, actually. The transport layer is responsible for the flow of data to and from the destination computer. The source and destination computers decide on an appropriate amount of data that can be sent at one time. They also identify if the data needs to be transmitted in sequential order or simple one-packet transmission. The network layer provides a means of routing data packets across a WAN or a metropolitan area network. Sending a data packet across a LAN only requires the destination computer's MAC address. When sending a data packet across a WAN or a MAN, the packet must be encapsulated with an additional address, and that is specifically an IP address. The network layer is also responsible for virtual networks. A virtual LAN or VLAN is a logical network within a local area network. Virtual networks are created to help eliminate collisions and thus increase the bandwidth capabilities of a local area network. The data link layer converts the data package into electrical pulses, places those pulses on the network media. The data link layer is responsible for error checking. Checks such as parity are made to detect missing binary information. CRC checks are also performed at the data link layer. The physical layer, which is the bottom layer, is concerned with media, hardware, and topology of a network. The media may be infrared signals, copper wire, glass or plastic fiber, or even electromagnetic radio waves. And as always, remember to keep calm and remember to document everything.